Okay, the lesson for 9-5 on Algebra 2 lesson is about geometric series. Our objective is to define geometric series and find their sums. So our key concept, I would like for you to copy this in your notes, so pause if you must, and copy it. It says the key concept for the sum of a finite geometric series, for the sum S sub n of a finite geometric series, a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus ellipse plus a sub 1 times r to the n minus 1 with r not equal to 1 is this. So S sub n is equal to the first term, a sub 1, times 1 minus r, which is that common ratio, to the nth power, number of terms, all over 1 minus r, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. So this is what you need to know. Okay, that's our important thing here. Alright, and this is the sum of a finite geometric series. So first we're going to learn how to define them and then define their sums. Okay? So yesterday, I guess I'll back up, we talked about how to do a summation. And the sigma character, the sideways m, and we give it an upper and lower limit. We start with n equal to 1 and we go all the way to 58 terms. So this means we're going to sum from the first to the 58th term, and here's the formula to do that. 6 times n minus 5. So whatever n is, whatever term we're on, if we're on the 5th term, well, then you're going to substitute 5 for n, and it will give you the value of that 5th term. So 6 times 5 minus 5. So it would be 30 minus 5, so 25. The 5th term in this series is 25. Okay, now if you want to sum it all, we've got to apply our formula that we were given. Okay, so now let's talk about today's lesson. Okay, and there's another example there. So today this is a really short lesson. We're just going to learn problems, the first problem and the third problem, and then you're going to work problems 1, 2, and 4, and 9, 10, 11. So I started the Google Classroom, and I'll just show you that real quick. For this lesson, you're going to learn problems 1 and 3, and from your practice K, you're going to work problems 1, 2, and 4 on 9-5. And then for 9, 10, and 11, you're going to tell only if it diverges or converges. So quite easy assignment here today. So we're just going to learn problems 1 and 3. So let's do that now. Our essential understanding, just as with finite arithmetic series, you can also find the sum of a finite geometric series using a formula. You need to know the first term, the number of terms, and the common ratio. So again, you have to know the first term, so that's the a sub 1, the number of terms, that's your n value, and the common ratio, which is r. So those are the 3 things we need to know. So a geometric series is the sum of the terms of a geometric sequence. So when we look at problem 1, and like I said, we're just going to be doing problems 1 and 3 problems out of the workbook, and then problem 3 and 3 more problems. Then we'll be done with this chapter. So problem 1 says finding the sums of finite geometric series. So finite means it has a specific number of terms. There's no ellipses. It has a beginning and an end. It doesn't go to infinity. So what is the sum of the finite geometric series? My husband's asking, when are you coming home? So we have 3 plus 6 plus 12 plus 24 plus ellipse plus 3,072. So they want to know, what is this sum? So what were the three things we needed again? We need to know the first term, the number of terms, and the common ratio. So we need a sub 1, the number of terms, and the common ratio. So that a sub 1 is easy, that's 3. Our number of terms, we're not certain because this goes quite a long ways and we're missing many in between. And we can find this, right? Because if it's a geometric series and they're telling us that, we can just do one set and get our R. So we have to get our common ratio first. And remember, to get the common ratio, you're just going to go to your second term, 6 divided by 3, which is 12 divided by 6. Excuse me. They're going through all these. Let me back up. 6 divided by 3, and then the next set is 12 divided by 6. The next set is 24 divided by 12. So they're checking all the ones that we were given. And when you do that, you find 6 divided by 3 is 2, 12 divided by 6 is 2, and 24 divided by 12 is 2. So we have a common ratio of 2. So R equals 2. And we know that the very last term, the nth term, whatever n is 3,072. We just don't know what n is. We do know the first term is 3. We know the common ratio is 2, but we don't know n. So now we're going to have to use that formula and solve for n. So use your explicit formula. And let me clear all this up. There we go. So a sub n equals a sub 1 times r to the n minus 1. So there was our explicit formula from a previous lesson. And we know our very last term, a sub n, is 3,072. So substitute that. And then we know our first term is 3, so substitute that. And then we know our ratio r is 2 to the n minus 1. So we don't know n, that's the only thing. So we've got everything in here but n. So now, continue to solve. So divide both sides by 3, and then that'll go away, and that'll go to 1,024 equals 2 to the n minus 1 power. So if 1,024 is 2 to the 10th power, so n minus 1 is equal to 10, and n is equal to 11. So you might wonder, how did we know that 1,024 is 2 to the 10th power? Well, if you just start playing with powers of 2 to figure out which power of 2 is 1,024, on your calculator you would quickly find out that it's 2 to the 10th power, right? Because 2 times 2 is 4, so there's your second power. And 4 times 2 is 8, there's your third power. 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64, and so on and so forth, till you would get down to the 10th power, and you would see that is 1,024. So if 2 to the 10th power is 1,024, and 1,024 is equal to 2 to the n minus 1, well, that's equal, or 2's are equal. That means that n minus 1 is equal to 10. See, right there. N minus 1 is equal to 10. So, solving for n, add 1 to each side. N is equal to 11. So now we've got our n. N is equal to 11. Okay. So we have our first term, we've got our ratio, or r, and now we have our number. So now we can plug it into our sum formula. So S of 11, see, all of our n's are going to be 11 now, right? And we know our first term is 3. And what's our common ratio was, what, 2. So you plug everything in and solve. And when you do, you get that it's 6,141. And that's all there is to these. And if you look at problem 1, they basically work the whole thing for you, just like we've worked here on problem 1. So in your workbook, it says find the sum of each finite geometric series, and you're doing the same thing. It's the same type of problem, just different terms. Okay, so you do it the exact same way, and they coach you through the first problem, all the way down to the last answer. And all you have to do is fill in the box, basically, there. Then use that same technique to do number 2 and number 4. Okay, so on your workbook now, I want you to work number 1, number 2, and number 4. Okay, so let's move on to our last problem. Set, and this goes with problem 3, and we need to learn that the terms of a geometric series will grow rapidly when the common ratio is greater than 1. Sort of like an exponential series, right? It starts out slow, then it shoots off. So likewise, if they grow rapidly, that means they're going to diminish rapidly when the common ratio is between 0 and 1. So in fact, they diminish so rapidly that an infinite geometric series has a finite sum. Okay, sort of mind-blowing to think about, right? An infinite geometric series has a finite sum. Well, it's because they diminish so rapidly that it basically just might as well be 0, right? So let's look at our key concept on infinite geometric series. An infinite geometric series with the first term a sub 1 and a common ratio, and now they're using absolute value of r is less than 1, has a finite sum. And that is this. The sum is equal to the first term a sub 1 over 1 minus r. So an infinite geometric series with absolute value of r greater than or equal to 1 does not have a finite sum. So if it's infinite geometric series with the first term and a common ratio of the absolute value less than 1, it has a finite sum. So if it's between 0 and 1, we can say it has finite. If it is greater than 1, the common ratio, absolute value of the common ratio is greater than 1, it does not have a finite sum. Okay, so remember, your instructions on this one was tell only if it diverges or converges for 9, 10, and 11. So let's look at what makes it diverge or converge. So let's look at problem 3. Okay, so before we get there, let's learn about how to tell if it diverges or converges. So if the absolute value of the ratio is greater than or equal to 1, it's diverging. It diverges. If it's between 0 and 1, then it converges. So that's all I want you to tell me is look at 8, 9, 10, and 11 and tell me, well, 8's already done for you. So 9, 10, and 11, tell me if it converges or diverges. Okay? So let's do one together. It says problem 3, does the series converge or diverge? If it converges, what is the sum? So we're not going to worry about what the sum is, okay? I just want you to tell me, does it converge or does it diverge? Okay? So remember, let me back up. If it's greater than 1, it diverges. If it's between less than 1, it converges. Okay? And we ignore the negative sign. We're just taking absolute value. So whatever r is, strip the sign. If it's greater than 1, it diverges. If it's less than 1, it converges. I guess we can remember it like this. Greater than 1 is the greater letter. D is greater than C, right? Greater than 1, diverge. Less than 1, so it's the lesser letter, C. So let's look. we're going to look at the common ratio. So how do we do that? Remember, we're going to divide. So go to your second term, 1/2 divided by 1. Well, 1/2 divided by 1 over 1. What do we do? Flip the second term and multiply. What is it equal to? 1/2. So that's between 0 and 1. So it does what? The lesser one, it converges. So that's all you're going to tell me. Now let's look at the next problem. We're not going to worry about the sum for this assignment. Now let's look at the next one. Actually, you're not going to work any like this one. We're not going to work any of those. Oh, my husband is going crazy because I'm still up here. All right, so let's look at number 8 together, okay? So we're going to look and see if it diverges or converges. Goodness gracious, I had lots on here. All right, so number 8 on your workbook on the back page, we had 1 plus 1/4 plus 1/16. So let's get our common ratio. So we're going to go 1/4 divided by 1. Well, we know there's 4/4 and a whole, right? Or if you want to do it the fraction way, 1/4 divided by 1 over 1. What do? Flip the second term, which when we flip it, it's the same, and multiply. So it's equal to 1/4, okay? So that's between 0 and 1, so it's the lesser letter C, converge. This converges. And that's all you're doing. That's all I want to know. So don't worry about what the total is. Just tell me, do these converge or diverge? Now, let's look at number 9. We have 2 plus 8 plus 32 plus ellipse. Does it converge or diverge? Okay, so we're going to go 8 divided by 2, which is 4. That's greater than 1, so it diverges. Okay, and now do 10 and 11 on your own, okay? And that's it. That's it for this chapter. And now you can go onto your study guide. If I'm not back yet, you're welcome to go onto your study guide, and I've made the copies, and I will also post it in Google Classroom. And that concludes this lesson. Turn it in before the end of the hour, and thank you. This concludes our chapter and our video.